KCET 2025 aspirants, welcome to 60 out of 60 KCET Chemistry 2025 series in just 200 days. So yes, we have started a series where we are going to cover each and every topic of chemistry and we'll be solving a lot of questions and we'll also be practicing the PYQs simultaneously. Okay, so if you are someone who is going to write the KCET 2025 examination, then this series is for you. Okay, so yes, today is the first lecture for this and today we are going to discuss one of the most important and the high weightage topic, that is solutions. So today we'll be talking about the type of solutions, the concentration terms and the solubility. So one important reminder here, please join our WhatsApp channel because whatever I'm teaching, the notes will be provided in our WhatsApp channel, the questions will be provided in the WhatsApp channel and the test questions will also be there. So yes, the link of the WhatsApp channel will be there in the description section of this video. So please go there and join the WhatsApp channel. Okay, so yes, now I want all of you who are interested, who are going to study, please take a notebook and a pen and sit with me and write down and note down all the important concepts that we are going to cover. Okay, so yes, now let's get started here. So first I will be telling you how are we going to cover this particular topic, how many lectures will be there and in which lecture which topic I am going to cover. Okay, so that you can have an understanding that which day this chapter will getting covered. Okay, so first of all, in solutions chapter we will be having 3 lectures, video 1, video 2 and video 3. Okay, so in the first one, that is today, we are going to discuss 3 topics that I have already told you: types of solution, concentration terms and solubility. Okay, now coming to the second lecture of this topic, we will be having the fourth topic, that is vapor pressure, and the fifth topic, that is ideal and non-ideal solutions. Now the third video will be coming on this topic where we will be discussing about the sixth topic, that is colligative properties, and the seventh topic, that is abnormal molar mass. Okay, so I can tell you the entire solutions chapter I have divided in 7 topics and the first lecture will be covering these 3 topics, in the second lecture these 2 and the third lecture these 2 topics. So entirely in 3 lectures the whole chapter will be covered. A lot of questions will be practiced and some PYQs also be solved. Okay, so yes, if you are continuing this series after the end of these 3 lectures, you would have mastered the solution chapter. I guarantee you that. Okay, so now we will discuss something about the weightage of this particular topic in your KCET 2025, like in your KCET examination. Okay, so if you see, I have made a table where I have analyzed the previous year papers from 2017 to 2024 and I have checked like how many questions have been asked from this particular chapter. So you can see in 2024 3 questions were asked, in 2023 also 3, 2022 5 questions were asked, in 2021 4 questions, 2020 5 questions, 2019 2, 2018 2, 2017 3. So if you see the last 5 years of trend, then we can say that from this particular topic you can easily expect 3 to 5 questions, right? So and that is a huge number. Okay, so to get 3 to 5 marks from one particular topic, just you need to cover them, you need to understand some basic concepts, basic formulas, then easily this chapter is doable. Okay, so yes, this chapter, that is why, is a very high weightage topic. So now let us start with our lecture. The first topic, I told you today we are going to discuss 3 topics. The first topic is solution and its types. Okay, so now based on the, so for example, I will tell you some important first terms that you need to understand. The first term I will tell you is what is a solvent, okay, and what is a solute. So generally what we think that solvent is something which is present in more amount. Okay, that component of a solution which is in more amount is called as solvent. Now what is a solute? Solute is that component which is present in less amount. Okay, now what is solvent plus solute? If I add, we will get solution. Okay, now you see, in a solution we have 2 things, one is solute and one is solvent. Now based on the physical state of the solvent, okay, physical state of solvent. So what can be the physical state of solvent? It can be gas, liquid or solid. We can have different types of solutions. Okay, so you can see here Based on the physical state of solvent, we would have solid solutions, we can have liquid solutions, and we can have gaseous solutions. So what type of questions can be asked from this? You need to remember the examples. 1 or 2 examples you need to understand. So I'll show you a table. So yes, this table is there in your NCERT book. Okay, so you can now see here, for example, if I take gaseous solution, in gaseous solution the solvent has to be gas, then gas in gas, liquid in gas, solid in gas. Okay, that is gas in gas, or liquid in gas, and solid in gas. And you also need to remember their examples. So like for example, oxygen and nitrogen. Okay, you can see here 2 are gases, that is an example of gas and gas solution. Liquid and gas, chloroform in nitrogen gas. So this is my solvent, this is the solute. Solid, so camphor in nitrogen gas, again solid in gas. Okay, now coming to liquid solutions. Here in liquid solutions, what is there? The solvent is liquid. Okay, and you can have gas in liquid, liquid in liquid, and solid in liquid. Now if I see gas in liquid, then oxygen dissolved in water. Oxygen is the gas, which is the solute, and water is the solvent here, right? Now coming to liquid in liquid, ethanol in water. Ethanol is a solute which is liquid, and water is a solvent which is again a liquid. Now coming to solid and liquid, glucose dissolved in water. Okay. Now coming to the next type of solution, that is solid solutions. In solid solutions, what we have? The solvents are solid, and we can have gas in solid, liquid in gas, liquid in solid, and solid in solid. So now if you see the examples here, solution of hydrogen in palladium. Okay, this you would have used in electrochemistry when we prepare the hydrogen electrodes. We adsorb hydrogen gas on platinum rods, right? That is an example. Next, amalgam of mercury with sodium. So liquid with solid, mercury amalgam is an example. Next, solid in solid, copper dissolved in gold. Okay, so yes, these are the different types of solutions, and what is the basis of this classification? The physical state of the solvent. Okay, so this much is there in the first part. So what you have to do, very simply, you have to just go through this table once, and that's done. Okay, now let us move to the second term here, which is very, very important, that is concentration terms. So in our chapter we have 7 concentration terms. Okay, so now let us see. First is mass by percentage. Second, volume by percentage. Third, mass by volume percentage. Fourth, parts per million. Fifth, mole fraction. Sixth, molarity. And seventh is molality. Now why these 3 I have highlighted? This is because these 3 are very important. Okay, many numericals are asked from these 3 types of concentration terms, but we will cover each one of them in detail. So let us move to the first concentration term, that is mass by mass percentage. Now from this, okay, here mass by percentage, so here I have missed, it is mass by mass percentage, volume by volume percentage. Okay, now let us see the first one, that is mass percentage. Now here what happens, the formula, okay, mass percentage of a component is equal to mass of the component in the solution by the total mass of the solution into 100. Okay, now the formula might be little complex, but it is very, very simple thing. Now see, for example, suppose I have told you that in this particular container, okay, there is a container, okay, and here the level, this is labeled as 10%, okay, 10% glucose, and I gave you this bottle. Now what you will understand from this, what 10% glucose, what does it mean? So you have to understand that total, so I told you there are 3 things: solution, okay, solvent, and solute. Okay, so now if I say that it is 10% glucose, that means glucose is the solute, and generally solvent we consider as water. So if I say 10% glucose, that means 10 gram of glucose is there. 10 gram of glucose is there. Okay, so solute is how much? 10 gram. Okay, then 10% means the total solvent, sorry, the total solution is 100 gram. Always when you use the word percentage, that means the solution mass is 100 gram. So this is how much? 100 gram. Okay. Now this solvent and solute makes the solution. So if solution is 100 gram, solute is 10 gram, then how much will be solvent gram? Solvent will be 90 gram. And in this case, our solvent is water and solute is glucose. I hope this is clear. Now a small task for you, you need to comment down the answers for this. If I tell you that it is 20% HCl solution, you have to comment down what is the mass of HCl. Okay, then you have to comment down mass of water, and then you have to comment down mass of solutions. If you have understood this one, then this one will be very, very easy. Okay, clear? Okay, now how to solve questions, what type of numericals are asked from here. So we'll do a small, very simple question. Suppose question I'll do here, one small question. Suppose 40 gram of, I'll tell 40 gram of calcium carbonate, okay, is dissolved in 80 gram of water. 40 gram of calcium carbonate is dissolved in 80 gram of water. Then what is the mass percentage of calcium carbonate? Mass percentage of calcium carbonate. So what to do? Mass of the component. Which component is added? Calcium carbonate. So total mass of this one is 40. Next, total mass of the solution. 80 gram is water, 40 gram is calcium carbonate. The total mass of the solution will be 120, right? Then into 100. Okay, so now you can just solve this. So 33.33 something will get. Okay, so this is the mass percentage. Now if I tell you that 33.3% of calcium carbonate is given to you, then what will you understand in that? The mass of calcium carbonate is something around like 33.3, mass of solute, mass of solvent you can calculate. Okay, I hope this is clear. Okay, now let us go to the next part here, that is volume percentage, VYB. Okay, now this is also very similar to what we have seen as mass percentage, but here instead of mass we'll take volume. So volume of the component in the solution by the total volume of the solution into 100. Okay, so if you calculate that, then we will get this formula, that is volume by volume. Now let us see one example here. If I tell you 10% of ethanol is there, okay, 10% of ethanol. We have again three things. Volume. In the previous example we were talking about mass. In this example we'll talk about volume. So I have volume of solvent or volume of solute first, then I have volume of solvent, right, and then I have volume of solution. Okay, so now if you see here 10% ethanol, when I am saying the volume of the solute is 10 ml. Okay, volume of the solution, whenever I am using percentage, it is 100 ml. Then what is the volume of the solvent here? Volume of the solvent will be 90 ml. Okay, clear? Same way we can solve question also. Suppose some mass is some volume is given, volume of the solvent is given, you need to add the volume of the solvent and then calculate the percentage. Now let us go to the third one here, mass by volume percentage. Okay, mass by volume percentage. Now what is this one here? Here the mass of the component is the mass of the component in the solution divided by the total volume of the solution into 100. Okay, mass by volume. So mass of the component you will take, but volume of the solution you will take. In the mass by mass we took mass of the component, mass of the solution. In volume by volume we took volume of the component by volume of the solution. Here mass by volume will take mass of the component but volume of the solution into 100. Okay, so I'll give an example here. Suppose I'll tell that 10%, okay, W by V. Okay, we represent it as W by V. W stands for weight, V stands for volume. 10% W by V of calcium carbonate. Okay, so what does that mean? The definition is very important. It is that means that 10 gram of calcium carbonate, okay, is present in 100 ml of solution. Okay, we do not know the solvent mass here. We do not know anything about the solvent. We know solute mass is 10 gram and volume of the solution is 100 ml. Okay, so this is very, very important. Many a times this definition should be clear to solve different numericals. Okay, I'll tell you that how, when it is required to understand the definitions. Now coming to the next one here, parts per million. Okay, parts per million formula is number of parts for that particular component divided by the total number of parts into 10 to the power of 6. Now what is the use of this parts per million? It is used when we want to represent trace or a very less amount of concentration. Okay, for representing small amount of concentrations like the salt in sea of water, okay, or some very small concentrations if you want to represent, then we need to use parts per million. Okay, so one example I'll give you. So a liter of sea water, so 1 liter of sea water is there. The weight of this one is 1030 gram. Okay, contains 6 into 10 to the power of minus 3 gram of dissolved oxygen. So how much oxygen is present? 6 into 10 to the power of minus 3 grams. Okay, now this small concentration, to represent that, what we have to do, if you have to just take the mass of the component is how much? 6 into 10 to the power of minus 3 divided by the mass of the total component, that is 1030 into 10 to the power of 6. Okay, so now if you solve this, we'll be getting 5.8 into 10 to the power of 6, or we can say that 5.8 ppm. Okay, so that is how this this is used, just to represent very trace amount of solute present in a solvent. Okay, the next concentration term here is your mole fraction. Okay, so mole fraction is going to be a very, very important topic here, because like most of the numericals or most of the colligative properties that we are going to study will be on the basis of mole fraction. Okay, so how to calculate mole fraction is very, very important. Now this very, very easy concept, number of moles of the component divided by the total number of components. Okay, number of moles of the particular component divided by the total number of components. I'll give an example here. In a binary mixture, if the number of moles of A and B, so you just imagine that we have a mixture, okay, and here we have taken A and B. So we have some components of A and we have some components of B. Okay, now this is number of moles of A, okay, and here we have number of moles of B. Okay, so now what happens? You need to calculate the mole fraction of A. So how the mole fraction is denoted? So mole fraction is denoted by X of A. Okay, so this is X of A. Okay, now mole fraction is denoted by a chi formula and then A. So that will be equal to the number of moles of A. Okay, I'll take yellow pen here. Number of moles of A divided by number of moles of A plus number of moles of B. Okay, now if I want to represent chi B, how to represent? Number of moles of B by number of moles of B plus number of moles of A. Now what is the relation between XA and XB? This is also very important. You should know XA or chi A plus chi B is equal to 1. Okay, now what happens? Suppose, okay, suppose in a question you have been asked to calculate XA and XB. You can calculate XA, then again doing this much calculation for XB, it will be better. If you know this formula, you can simply subtract 1 minus XA to get XB, right? Okay, so next coming to the one question for you. Okay, let us solve this question. You also try this question and tell me whether you are able to solve it or not. Calculate the mole fraction. Okay, we need to calculate mole fraction of ethylene glycol in a solution containing 20% of C2H6O2 by mass. So here mass percentage concept is also important and mole fraction concept is also important. So now what is given here? 20% of ethylene glycol. Okay, now what does this mean? What is the mass of ethylene glycol? Mass of ethylene glycol, sorry, mass of C2H6O2. I hope you can answer this one when I say 20%, right? So if I am saying 20%, mass of C2H6O2 will be 20 gram, right? Then what is the mass of the solution? Whenever it is percentage, what should be the mass of the solution? 100 gram. Then what is the mass of solvent here? Solvent, we have to assume that it is water. So mass of solvent, or I can say water, is 100 minus 20, 80 grams, right? Now can we calculate the number of moles? Number of moles formula, you know, given mass by molar mass. So let us calculate the number of moles of ethylene glycol. Okay, so given mass by molar mass, so what is the given mass? 20. And what is the molar mass? So you can see 2 carbons are there, so 12 into 2, 24, plus 6 hydrogen, so 24 plus 6 is 30, then we have 32, so total 62. Okay, next if we calculate number of moles of water, again given mass by molar mass, what is the given mass here? For water it is 80, okay, and 80 by 18. Okay, so now what we have to do, we have to simply calculate the mole fraction of ethylene glycol. Mole fraction of ethylene glycol will be number of moles of, I am just writing ET, by number of moles of ET plus number of moles of water, right? So if I add this, what I'll get, I can cancel this one, 1 by 3, right? So we can get 1 by 3 divided by 1 by 3 plus, again if I cancel this one, I'll get 40 by 9. Okay, now if you solve this, we'll be getting around 0.068 mole fraction of ethylene glycol. Okay, so that is how very simply you can solve this question. But here little confusing or little tricky part is what? To understand how are we getting the masses from the mole fraction concept. Okay, now coming to the second concentration term, the sixth concentration term, that is molarity. Again a very important concept, molarity. Many questions are asked from here. So again the formula here is moles of the solute by volume of the solution in ml into 1000. Okay, here I want to mention, if your volume of the solution is in liter, then you need not multiply this 1000. Okay, so another formula I can say, molarity will be equal to, okay, you can write molarity is equal to number of moles of solute, okay, by volume of solution, okay, volume of solution in liter. If you are taking it as ml, milliliter, then you need to multiply 1000. Now I will also tell you what are the different units. You should know 1 liter is equal to 1000 ml, okay, and another term also is used, 1 liter is equal to 1 decimeter cube. Okay, this unit conversions you should know, because many a times with decimeter cube also we get the question. Okay, now coming to what is this W2 by N2? So number of moles I have written in this term. Number of moles is what? Given mass by molar mass, and the 2 subscript, okay, the 2 subscript represents solute, okay, and 1 represents solvent. Okay, so W2 is the given mass and M2 is the molar mass. So given mass by molar mass into 1000 by volume of solution in ml. Okay, now I'll tell you very important thing, how do we represent it? So it is represented with capital M. Okay, so okay, I have an example here. So for example, you have 0.25 molar NaOH. Okay, 0.25 molar NaOH. So I'll clear this part little bit so that it will be visible. 1 second. Okay, so I'll write it on the other side. Okay. Okay, so 0.25 molar NaOH, what does it mean? Now see, when I'm saying that 0.25 molar NaOH, that means 0.25 moles, okay, of NaOH is dissolved in 1 liter of solution. Okay, this is very important to understand. 0.25 molar NaOH means 0.25 moles of NaOH has been dissolved in 1 liter of solution. Okay, so what you have done, basically you have taken a container, okay, solution, you have made it 1 liter, and then here you had added 0.25 moles of NaOH. Okay, then there will be, after adding this, we'll get a solution. The concentration of this solution will be 0.25 molar. Okay, so I'll rewrite that formula here. Molarity can be, or can also be equal to number of moles of solute, okay, divided by volume of solution in liter. Okay, and here I'll represent 2 represents solute, okay, and 1 represent solvent. Clear? So that when you download the notes, there won't be any problem for you. Now coming to a question here. Calculate the molarity of a solution containing 5 gram of NaOH in 450 ml of solution. So this is very direct question. Let us note down the data as given. So W2, okay, mass of the solute is 5 gram, right? Now what is M2 here? Mass of NaOH, so that is 23, 23 plus 1, 24, 24 plus 16 is 40. So mass of this one is 40 grams, right? Next, volume of solution is how much? 450 ml. Okay, now let us try this question. So molarity is equal to, okay, molarity is equal to 5 gram by 40. You remember the formula? I'll write down the formula for you once. W2 by M2 into 1000, right, by volume in ml, volume of solution. So W2 by M2, that is 5 by 40 into 1000, okay, by 450. So now solving this is your part. So if you solve this, you will be getting around 0.278 molar. So units you should remember capital M. Okay. Now let us go to the next topic, that is molality. The last concentration term. We have listed 7 concentration terms. So this is the last one. Okay, it is denoted by small m. So molarity and molality, slight difference is there. So here you can see number of moles of the solute divided by mass of the solvent in grams. What was there in molarity? Volume of the solvent in ml. Here it is mass of the solvent in grams, right? Volume of the solution in molarity, and in molality mass of the solvent. Very small difference that you must remember. Okay, now coming to here the formula can also be number of moles of the solute, okay, by mass of solvent in kg. Okay, so if you are taking it gram, then you need to multiply 1000. Okay, now again number of moles of solute can be represented as W2 by M2, okay, into 1000 by mass of the solvent in gram. Clear? Next we will take an example. Suppose it is given to you that 1 m of KCl solution. Okay, what does this represent? So we have first thing 1 mole of KCl in this. Okay, 1 mole of KCl is present in what? Is present in 1000 gram, or I can say 1 kg of solvent. Okay, so here solvent, if it is not mentioned, we take solvent as water, right? So you have taken 1 kg of water and you have added 1 mole of KCl. The solution that is formed here, its concentration is 1 m or 1 small m. Okay, now again we'll do one question from here also. Calculate the molality of 2.5 gram of ethanoic acid in 75 gram of benzene. Okay, very simple question. So I'll write down the data here. W2 is 2.5 gram. Okay, now ethanoic acid, we need to calculate M2 here. Okay, and I have mass of solvent, that is benzene here. Okay, so every time it need not be water, it can be any solvent, that is 75 gram, right? Now if I see M2, CH3COOH, so I can write it as C2H4 and O2. So 12 2s are 24, and then we have 4 here, oxygen is 32, right? So if we add it, how much will get? 4 plus 4, 8, 9, 10, 3 to 5 plus 1, 60. So I have 60 grams. So molar mass of the solute is 60 gram. Okay, now let us calculate the molality. So given mass, that is 2.5 gram, okay, divided by molar mass, 60 gram into 1000, okay, by mass of the solvent is 75. So now the calculation part is yours, but if you will be solving this, you will be getting around 0.556 molar. Okay, you see the unit should be small m here. Okay, Now coming to next one. So here I have taken one question where I have mixed all the concepts, okay, and I have asked you to calculate the molality, molarity as well as mole fraction, okay. So let us do this question. First try it by your own. If you are not able to solve the question, then see the solution, okay. Okay, now let us read this question properly. Okay, calculate molality, that is small m, molarity capital M, and mole fraction, okay, of Ki, okay, if the density of 20% mass by mass aqueous Ki is 1.202 gram per ml. Many of you might have been confused, ma'am, from where density has come, okay. So everything we'll understand step by step, okay. So first of all, tell me what is the meaning of 20% mass by mass. So if you see, I have explained you 20% W by W. This is given, right? So from here, what information I can get? I can get the mass of solute. So I'll write here mass of Ki. Solute is Ki, right? So mass of solute is 20 gram. And what is the mass of solvent? Aqueous solution is given. That means mass of solvent is 80 gram. Why? Because percentage is given, that means total mass is 100 gram. Out of that 20 gram is Ki, then 80 gram will be what? 80 gram will be water, okay. Now let us first calculate the molar mass of Ki, okay. So if you add this one, the molar mass of Ki, if you remember, potassium is 39 and iodine is 127, right. So if I add this one, we'll get 166 gram per mole, okay, molar mass of Ki. So now let us start the first part, that is calculation of molality, okay, molality. So molality formula is what? Given number of moles of solute by mass of the solvent into 1000. So number of moles of solute will be 20 given mass by molar mass, right, into 1000 by mass of the solvent is 80. So now if I solve this, okay, you will be getting around 1.506 and that is molality. Clear? Very easy and simple, the first part, okay. Now coming to molarity. Here you need to be very clear that why this density is given. See, now what is the formula of density? Tell me. Density is equal to mass by volume. And for molarity, if you have remembered molarity formula, it is number of moles of solute divided by the volume of solution. We need volume of solution. Here nowhere we are having the volume of solution. So for that we need to use the data of density. So now what is volume of solution formula? Volume of solution will be mass by density. Now from the mass percentage we know, that mass of solution will always be how much? 100 gram, right. So I'll substitute here, mass of the solution is 100 gram and density is 1.202 gram per ml, right. So I'll get 100 by 1.202 ml, okay, 100 by 1.202 ml. This is your volume of the solution. Now let us calculate molality, molarity, capital M. So again number of moles of Ki is same, 20 by 166, right, into 1000 by volume of this solution will be how much? 100 into 1.202. Okay, I'll write it in this form, one second. So it is 100 by 1.202, okay. So now if I solve this, we will be getting around 1.448, that is capital M, molarity, okay. Now third part is very easy. You need to calculate the mole fraction of Ki. So mole fraction of Ki is what? Mole fraction of Ki will be equal to number of moles of Ki divided by number of moles of Ki plus number of moles of water, right. So we know given mass of water is 80, number of moles will be 80 by 18 and number of moles of Ki is already 20 by 166. So I'll substitute here, so I'll get 20 by 166 divided by 20 by 166 plus 80 by 18, okay, given mass by molar mass. So if I solve this, okay, then you will be getting around 0.026, okay. The mole fraction of Ki will be 0.026, okay. So yes, this is how you can solve it, and please check your answers. So I'll be highlighting the answers here. The first one is this one, B answer will be 1.448 and the C one will be 1.026. Okay, so just check, and if you have any doubt in this question, you can comment down. Okay, I'll address it. Okay, now let us go to the third topic of our lecture and the last topic, that is solubility. So what do you mean by solubility? So solubility means, okay, maximum amount of solute, sorry, solubility means maximum amount of solute, okay, that can be dissolved, maximum amount of solute that can be dissolved in a given amount of solvent, at a particular temperature. Okay, temperature should be maintained constant at a particular temperature. Okay, now solubility will be studying in two parts. Okay, one is solubility of solid in liquid, the next part is solubility of gas in liquid. So for example, solubility of solid in liquid example is if you are dissolving salt in water, okay, or you are dissolving sugar in water, right? Now example of solubility of gas in liquid is, for example, oxygen gas is dissolved in water, okay, or carbon dioxide gas is dissolved in water. Okay, so we'll be studying these two topics in separately, like what is solubility of solid in liquid, what is solubility of gas in liquid. Okay, so let us see the first one, solubility of solids in liquids. So what are the factors in which the solubility of solids in liquids will depend? So there are three important factors. The first factor is the nature of substance. When I'm talking about your nature of substance, what is the substance here? Nature of solvent and nature of solute. The next one is temperature. Okay, the third one here is pressure. So the solubility of solid in liquid depends on three factors, that is nature of the substances, temperature and pressure. Okay, I hope this is clear. Okay, now let us understand how does nature of substances will work. Okay, so here one very simple concept is there, like dissolves like. So solute and solvent nature should be same. Okay, and when I'm talking about the nature, we are talking about polar and non-polar. So polar solutes will dissolve in polar solvents, non-polar solute will dissolve in non-polar solvents. Okay, so now for example, salt and sugar are soluble in water, right? Salt and sugar are polar and our water is a polar solvent, it dissolves in that. Now but if you, naphthalene and anthracene will not be dissolving in water. Why? Because naphthalene and anthracene are non-polar and water is polar. Okay, but naphthalene and anthracene will be dissolving in another non-polar solvent, that is benzene. Okay, I hope you are getting. See, one second, suppose we have polar solute, then I need a polar solvent, then there will be, they can dissolve in each other. Polar solute will dissolve in polar solvent. Similarly, non-polar solute will dissolve in non-polar solvent. Okay, I hope this example is clear. So very simple thing, like dissolves like. Okay, next coming to the temperature factor here. Temperature factor, you need to understand two things, that when we dissolve a solid in a liquid, okay, the process can be exothermic or can be endothermic. So if the process is endothermic, means heat is required to dissolve. So what do you mean by endothermic? Heat is required to dissolve the solid, okay. If it is endothermic, then heat is required to dissolve that solid. In that case, if you increase the temperature, solubility will increase. Okay, increases with temperature. What increases? Solubility. Solubility increases with temperature. If the dissolution process is exothermic, means what? Heat is released or heat is released. Okay, in that case, if you increase the temperature, then the solubility will decrease. So decreases with increase in temperature. Okay, decreases with increase in temperature. So I'll write it clearly. Decreases with increase in temperature. Okay, when you increase the temperature, the solubility will decrease if it is an exothermic process. Now generally the dissolution process is endothermic. Okay, generally, but not always, but generally the endothermic dissolution process is endothermic. Therefore when we increase the temperature, solubility increases. Okay, now coming to pressure here. So pressure, very thing, nothing to study, there is no effect. There is no effect of pressure on solubility of solids and liquids. Now what is the reason for this? The reason for this is solids are incompressible. Okay, so that is why there is no role of pressure here. I hope this is clear. So let us revise this once again. Solubility of solid in a liquid depends on what all factors? 3 factors. First factor is nature of substance. In nature of substance, what we are talking about? The nature of solute and the nature of solvent. So very clear, if the solute is polar, solvent has to be polar. If solute is non-polar, solvent has to be non-polar. I hope this is very clear. Now coming to second thing, temperature. Here also 2 cases, whether the process is endothermic or exothermic. If it is endothermic, then if you increase the temperature, solubility will increase. If it is exothermic, solubility will decrease if you increase the temperature. Okay. Now coming to third factor, nothing to study, pressure. There is no effect of pressure because solids are incompressible. Okay. Now let us go to the next topic, that is solubility of gas in liquids. Okay, this is very important concept, solubility of gas in liquids. So here there are 2 factors that is affecting. One is your pressure and the other factor is temperature. Okay, so pressure, what happens? If you increase the pressure, solubility will increase. Okay, solubility increases. Okay, solubility increases with the increase in pressure. Now in temperature, what happens? Solubility decreases with the increase in temperature. Okay, solubility decreases with increase in temperature. When you increase the temperature, the solubility will decrease. Okay, so now this part, okay, this part, that with pressure how the solubility is increasing, this was explained by a very famous scientist, that is Henry. Okay, so we study the solubility of gases in liquids with pressure because of Henry's law. Okay, there is one law called as Henry's law, which talks about, or which tells us that when we increase the pressure, the solubility of the gases will increase. Okay, so there is a liquid, there is a gas above it. If you increase the pressure, then the solubility of the gas in the liquid will increase. This is told by Henry, who has worked on it, and we study Henry's law on this. Okay, so let us go to next topic, that is Henry's law. Okay, so statement is required in your board exam, so please remember the statement correctly and write it correctly. So Henry's law is a gas law which states that the amount of gas that is dissolved in a liquid is directly proportional to the partial pressure of that gas above the liquid when the temperature is kept constant. Okay, so suppose I have a container here, okay, and here there is liquid and here is some gas. Okay, there is some gas particles here. Okay, so the solubility of this gas in this liquid will depend on the pressure of this gas. Okay, clear? There is a container, there is a liquid, above the liquid there is a gas. So how much gas will dissolve in this liquid will depend on the pressure of the partial pressure of this gas. So now how is it represented mathematically? Pressure of the gas is equal to KH into gas. So what I can say, see, pressure, we can write it like this. Solubility is expressed in terms of mole fraction here. Okay, remember, solubility is expressed in terms of mole fraction. So what I can say, that mole fraction, the solubility of a gas in a liquid is proportional to the partial pressure of the gas, right? I can also write like this, partial pressure of the gas is proportional to mole fraction of the gas. Now to remove this proportionality, we need to multiply a constant, and that constant is called as Henry's constant. Okay, so you can see the terms here. P gas is partial pressure of the gas, KH is Henry's constant, and the X gas represents the mole fraction of the gas. Now see, this is a small diagram that I was showing you, that earlier you see, suppose this one, this gray color part, can you see here? this gray color part, okay, that is the solution, and this is the gas present above it. Okay, now what you are doing, you are adding, this is a piston attached to the container. Now you are adding the weights. Okay, you have added more number of weights. So what will happen in that case? More number of gas will start dissolving into the liquid. Okay, so that is what is given by Henry's law. Very simple law. The solubility of a gas in a liquid depends on the partial pressure of the gas above the liquid. How much gas is present above that will affect the solubility of the gas in a liquid. Okay, I hope this is clear. This formula is clear. Partial pressure is equal to Kh into mole fraction of the gas. Okay, so yes, now let us go to the next part. Okay, applications of Henry's law. Okay, I'll tell you. What can you see here? Cold drinks bottle, right? So a question might arise in your mind, ma'am, why cold drinks bottle? So yes, there is a very good application of Henry's law in this one. Okay, so now you see, you must have observed like many of you, I am very sure, would have drank cold drinks, Sprite, Thumbs Up, Pepsi, right? So what happens when you open the cap? Have you seen that gas coming out from this, right? Why does that happen? Have you ever thought? That is because of Henry's law. See, when the carbon dioxide gas was dissolved in that particular container, a high pressure was given. Okay, and by giving that pressure, these carbon dioxides were dissolved in that liquid. Now when you, and then the cap was sealed. Okay, so this gas could not escape out. Now when you start opening the cap, you are releasing the pressure. Okay, that pressure with which that carbon dioxide gas was dissolved, now you are releasing that pressure. So as a result of what happens, that the pressure is decreasing, and we have discussed that pressure, if pressure is more, solubility is more, pressure is less, solubility is less. So when you are loosening the cap, the pressure is decreasing, so solubility will also decrease. So due to that, what will happen, that gas which was dissolved in this will come out, and we see it comes out so fast that we see as an effervescence. Clear this one? First application. Okay, to increase the solubility of carbon dioxide in soft drinks and soda water, the bottle is sealed under high pressure. So that is why when we open it, we release the pressure. When we release the pressure, solubility decreases and the gases comes out. Okay, next, very important. Can you tell what is this going on? What is this person doing? Can you identify them? Yes, it is scuba divers, right? I hope many of you would have a dream that I also want to do scuba diving, adventure, you want to do it. But here something we have also to study from Henry's law. Okay, so what happens is, the scuba divers have a tank with them. Okay, you might have seen, you can see here a tank with them. So now this tank is diluted with helium also. Now I'll explain you the complete process here. This gas, okay, when the diver goes deep into the ocean, what happens? Pressure increases. So pressure increases means solubility will also increase. So what happens? The oxygen gets absorbed, but at the same time nitrogen gas also gets absorbed. Okay, now the body absorbs a lot of nitrogen. Okay, now when the divers come out of the surface, okay, so we'll draw here and understand. Okay, let us not talk only, let us understand it with diagram. Okay, see, this is ocean, this is the top level, okay, and this is the bottom level. Okay, now here is one diver. Okay, just don't point out on the diagram. Okay, this is just to represent. Now when the diver goes down, okay, here what is the pressure? The pressure is very high. So as a result of what, a lot of gases get dissolved in the blood of this diver. Now when it comes out, again the pressure is decreasing, so that gas comes out which was dissolved. So we are talking here about nitrogen gas. So the nitrogen gas which was dissolved in the person's blood starts coming out, right? Now due to the abrupt coming out of the gases, there might be some bubbles formed in the blood vessels which causes a lot of pain. Okay, and this medical condition is called as bends. Okay, so now to stop this, what we do, actually the gas cylinder, the cylinders of these divers have been mixed with helium. Now what is the use of this now? The helium solubility is very less. Okay, so that is why helium gas, if it is mixed, the solubility does not it doesn't get absorbed in the human blood, and when it comes out also, it doesn't come out that rapidly. So the person can be relieved from this bends medical condition. Okay, that is why we add helium in the oxygen cylinders of the gases. Now question might arise, ma'am, why can't we take pure oxygen, right? So pure oxygen is also not very helpful, because there is something called as oxygen toxicity also. When too much oxygen get dissolved in the blood, that also is harmful. Okay, so that is why we cannot take pure oxygen. But if we take oxygen and nitrogen, then nitrogen will get more dissolved in the blood, and that can cause bends. So that is why oxygen, nitrogen and some helium is added. Okay, so that is why, so that this medical condition of bends can be prevented. Okay, now coming to third application here, that is your, okay, can you see this? What are they doing? Can you guess what are they? These are your mountain climbers, right? So what happens, you might have seen many times that when the mountain climbers go very high to the top of the altitude, they face some problem that is called as medical condition called as anoxia. Now what is this? Why this happens? This is because when we go up, okay, pressure is less, atmospheric pressure is less, so solubility of the gases will be less, so less amount of oxygen is dissolved in the human blood. Okay, and the person cannot like the brain does not function properly, okay, because the oxygen do not reach to the brain, and a person can have some defects or some problem, and this medical condition is called as anoxia. Okay, so you just, because KCET exam they won't ask you the applications, but there can be some questions on these particular medical terms. Okay, so that's why it is little important to understand these things. Okay, so now next coming to the effect of temperature. So we have discussed that in particular in solubility of gas in a liquid, we have two factors: effect of pressure, that is completely governed by Henry's law, and we have effect of temperature. Now I'll discuss something here. We know this is Henry's law formula: P of the gas is equal to KH into mole fraction of the gas, right? Now I'll write it in this way: X of the gas, so I can write it in this way, one second, yeah, I can write it as P of gas, okay, by X of gas is equal to KH. So what relation I am getting here? I am getting that KH is inversely proportional to mole fraction of the gas, right? KH is inversely proportional to mole fraction of the gas. That means what? If the mole fraction is more, or if the I can say solubility. So if KH is more, okay, then solubility will decrease. If KH is less, then solubility will increase, right? Inversely proportional. Now what happens with temperature? See, when temperature increases, okay, KH will increase. If KH will increase, then solubility of the gas will decrease. Okay, so that is why we can say that when temperature increases, the solubility decreases. That is because the Henry's constant also increases, and Henry's constant is inversely proportional to mole fraction of the gas. Okay, another way also you can see that in cold drinks, right? If you observe cold drinks, when it is very chilled one, the gas amount is more. As the temperature increases, the chillness of the cold drinks decrease, the gases also the solubility of the gases also decrease, and that is why we do not find it. So whenever we drink drinks, it should be chilled one, because we can find gas in that particular condition only. Okay, so now coming to the next one here. So here's one very simple question that you need to think: why aquatic species are more comfortable in cold water than in warm water? Okay, so this question I'm leaving it for you. Okay, you need to think the answers and comment down for this one. Okay, so this is very general logical question. Let me see how many of you have understood the concept of Henry's law. Okay, now coming to one numerical we'll be solving from your Henry's law question. Let us see the question here. If N2 gas is bubbled through water at 293 Kelvin, how many millimoles of N2 gas would dissolve in 1 liter of water? Assume that N2 exerts a partial pressure. So we have a partial pressure of N2 which is 0.987 bar. Okay, and we have been also given the Henry's law constant. Henry's law constant for N2 is 76.48. So kilobar is there. I'll convert it into bar. So I'll take 10 to the power of 3 bars. Okay. Now how many millimoles of N2 gas is asked? Okay. Now let us put the formula. P of N2 is equal to KH into mole fraction of N2. So I can write this one as P of N2 is equal to KH. For mole fraction of N2, I can write N of N2 by N of N2 plus N of water. Okay, because another component is water. Now what happens is, when we are dissolving such thing, we can assume that the number of moles of nitrogen is very less as compared to the number of moles of hydrogen. Okay, so number of moles of nitrogen will be very less as compared to the number of moles of water, not hydrogen, sorry, water. So we can ignore this number of moles of water. Okay, so I am writing what I am here, number of moles of nitrogen is very less than number of moles of water. Okay, so I can eliminate that. So what I'll get here, P of N2 is equal to KH into N of N2 by N of water. Now let us substitute the values here. Pressure of N2 is given to you 0.987 bar, KH is 76480. Okay, N of N2 I need to calculate, and water. So if you see, water is 1 liter and density of water, 1 liter means what I can say, volume is 1000 ml. Okay, and density of water, everybody must be knowing, it is 1 gram per ml. So what I can say, if I multiply density is equal to mass by volume, okay, and I multiply this term, I'll get mass of water as 1000 grams, right? So number of moles of water will be how much then? Number of moles of water will be given mass, that is 1000, by molar mass, that is 18, I'll be getting 55.5. Okay, so I can substitute that here. Okay, so now if I solve this, okay, if I solve this, we will be getting around 0.716 into 10 to the power of minus 3 moles. Okay, now if you see, the question has asked you to calculate millimoles. So converting moles to millimoles is, you have to multiply by 1000. So I'll get 0.716 into 10 to the power of minus 3 into 10 to the power of 3. So that is 0.716 millimoles. Okay, so how many number of moles of N2 will get dissolved? 0.716 moles. Okay, so here you should be clear that we can ignore this number of moles as it is very less as compared to number of moles of water. Okay, so now let us see. Okay, let us see now some PYQs. Okay, so an aqueous solution of alcohol contains 11 gram of, so sorry, this is 18 gram. Okay, one second. So this is just a minute. So this is 18 gram of water. Okay, small typing error. 18 gram of water and 414 gram of ethyl alcohol. So let us write down the values here. We have mass of water as 18 gram. Okay, and you know molar mass of water is also 18 gram, right? So then what is the number of moles of water? 18 by 18. So that will give me 1. Now let us see the mass of ethyl alcohol, right? That is your 46 gram. If you see, C2H5OH, right? So carbon 12 to are 24, 24 plus this one hydrogen 6, 30, 30 plus 16 is 46. Now if you see mass of ethyl alcohol, sorry, this given mass, one second, the given mass of alcohol is 414 gram and the molar mass is 46 gram, right? Now if I want to calculate the number of moles of ethanol, then it will be 414 by 46, right? So this is 9. Okay, so now let us calculate the mole fraction of water. So that will be equal to number of moles of water divided by number of moles of water plus number of moles of ethyl alcohol. So that will be equal to 1 by 9 plus 1. Okay, that will be 0.1. So the correct answer for this question will be option number C. Now coming to next one. Solubility of gas in a liquid increases with, okay, so we know solubility of gas in a liquid depends on two factors, pressure and temperature, increase in pressure and decrease in temperature. So the correct answer for this question will be option number A. Next, coming to question number 3. The Henry's law constant for the solubility of N2 gas in water at 298 Kelvin is 1 into 10 to the power of 5. Okay, so KH for N2 is given to you, that is 1 into 10 to the power of 5. The mole fraction of N2 in air, mole fraction of N2 is 0.8. Now the number of moles of N2 from air dissolved in 10 moles of water. Moles of water is there, so moles of water is 10. Okay, and at 298 Kelvin and 5 atm pressure is 5 atm, okay, is. So we know from Henry's law that P of N2 is equal to KH into mole fraction of N2, right? So you can see that mole fraction of N2 is given, KH is given, but P of N2 is not given. This pressure is not the partial pressure of nitrogen, this is the total pressure, right? Then how to calculate the partial pressure? So P of N2 is equal to mole fraction of N2 into P total. Okay, so now if I solve this, I'll get 0.8 into the total pressure is 5 atm, so that is 4 atm. Okay, now let us put this value. So pressure of N2 is 4 atm. One second. Okay, now one more thing, pressure of N2 is 4 atm, and we have xk value is given 10 to the power of 5. Okay, and mole fraction of nitrogen is number of moles of nitrogen by number of moles of nitrogen plus number of moles of water, right? Now just now we have solved one question. I told you whenever such type of question comes, number of moles of nitrogen will be very less as compared to number of moles of water. So we can ignore this one, right? So I'll ignore this one, and number of moles of water is given to you as 10. Right. So now if I solve this, I'll get 4 into 10 to the power of minus 4 is equal to number of moles of nitrogen. Okay. So the correct answer for this question will be option number C. Okay. Now coming to question number 4, choose the correct statement. KH value is same for a gas in any solution. KH value will be same, will be different for different gases, right? So this statement is incorrect. Next, higher the value of KH, more is the solubility of gas. We have just discussed that KH value and solubility are inversely proportional to each other. Next, KH value increases on increasing the temperature. Yes, this statement is correct. If you increase the temperature, KH value will increase, and that is why the solubility will decrease. Okay. Next, question number 5. The KH value of, okay, some KH values are given to you. First one is argon here. Okay. For argon, the KH value, second one is carbon dioxide, and third one is formaldehyde, and the fourth one here is methane. Okay. Now argon value given to you is 40.3, and carbon dioxide is 1.67, then formaldehyde is 1.83 into 10 to the power of minus 5, and methane is 0.413. Now the increasing order of solubility. So here we know that KH is inversely proportional to solubility, right? So if KH value is more, then solubility will be less, right? Increasing order means we need to find the least soluble. Least soluble means should have highest KH value. So that is argon, right? So argon should have the least solubility. So you can see these two options we can eliminate. This one option we can eliminate. Okay, others are all correct. Now after argon, whose value is there? Highest value, if you see, 1.67. So after 1, 2 should come. So we can eliminate these two options. The correct answer for this question will be option number A. Okay. Next, coming to, okay. So students, we have discussed the 3 concepts here. What are those concepts? Types of solutions, so concentration terms, and then we discussed about the solubility, and we have discussed 5 PYQs, and we have also discussed certain questions, little higher level questions also we have discussed. So now there is a task for you. So you have a small question here that you need to solve, and one question I asked you previous, that these 2 questions you need to solve. Okay. So question here is calculate the mass of urea required in making 2.5 kg of 0.25 molar aqueous solution. So I want all of you to solve these questions and comment down in the like you have to answer it in the comment section. Okay. So yes students, we have come to an end of the part 1 of the solutions chapter. Okay. So please let us know how did you like this lecture, or what if you did not understand any concept, please comment down. I'll definitely address it, and please comment down the answers. And one more thing, that please join the WhatsApp channel, do not forget. So whatever notes that we are given here, whatever questions that we'll be giving to you, everything will be provided in the WhatsApp channel. Okay. So do not forget to join the WhatsApp channel, link will be there in the description section. Okay. So please come wait for the next video on the solutions chapter, where we'll be talking about the next 2 topics, that is your ideal solutions and non-ideal solutions, and vapor pressure. Okay. So yes, till then please take care and wait for the next video. Thank you for watching, and please subscribe the channel for more updates.